In this next example, consider this case of the net sales of Walmart from 2011 to 2015. So we're given a graph here, which we can see the sales in 2011 were $421 billion, and in 2015 they were $486 billion. And so we want to estimate the sales in 2013. So now would be a good time maybe to pause the video and go ahead and see if you can estimate what you think the sales would be in 2013. One way to look at this is to simply say, well, okay, from 2011 to 2015, 2013 happens to be right in the middle. Okay, that's the middle year between those two endpoints. Okay, so you might say, well, if that's right in the middle, maybe my sales there would be right in the middle. So I could take the average of those two. So I could average and take the 421 plus the 486, divide that by 2. Okay, and when I do that, I would get 453.5. Okay, and that would tell me that the average sales between those 2 years, okay, which should be the middle point, would be about 453.5. So 453.5. And so that's exactly right. We're looking for the midpoint of this line segment. If you want to think of this more abstractly as a line segment, now here are 2 endpoints, and here is the midpoint along that line segment. Okay, the actual sales that year were 469 billion. Okay, so take a minute to think about, is that a good estimate for the sales by taking the midpoint? And in this case, you know, I'd say that's fairly good. Okay, you know, it might be a little higher up. It wouldn't be exactly on this line, but that's a decent estimate. Okay, but I encourage you to think a second about when this estimate might not be accurate. And one way it wouldn't be accurate is if the data was not linear. Okay, here we're making the assumption that all of these years in between are going to fall close to or on this line. Okay, so if we're talking about a graph that is not linear, okay, the midpoint would not be a good estimate of that. So let's talk now about how we actually come up with the midpoint. So we had this idea of finding the average before, and that's exactly what the midpoint is. It's really the average of the x values, okay, which are these values here, and the average of the y values, which will be these values here. And so if you think about, we just figured out the average of the y values because we already knew that 2013 was really the in-between value here, and you'll find that 2013 is the average of 2011 and 2015. Okay, so we kind of did that without knowing it. So if we consider here our midpoint formula, okay, and we can talk about m, the midpoint, it's going to be a point x comma y. Okay, we're going to describe it as a point. Okay, x comma y of the line segment from, we'll call it P1, okay, where again P1 is this point x1 comma y1, where x1 and y1 can be any ordered pair, to P2, which we'll call x2, y2. And so remember, this notation is just describing any random, not random, but any arbitrary point on the coordinate plane. So if we want to find the midpoint of this line segment that goes from P1 to P2, okay, we can do that by finding the midpoint. And again, that is going to be x and y values, where the x value is really just the average of your x's. So my average of x1 and x2 is going to be x1 plus x2 divided by 2. That's my x coordinate. And my y coordinate is the average of my y values. So y1 plus y2 divided by 2. Okay. So the midpoint of a line segment is the average of the x coordinates and the average of the y coordinates of the endpoints.